Welcome, everyone. Thank you so much for joining us today. My name is Joan Batorf, and I am a faculty member in the School of Nursing and director of the Institute for Healthy Living and Chronic Disease Prevention. Before we begin, I want to respectfully acknowledge that UBC Okanagan is situated on the traditional and ancestral unceded territory of the Syilx Okanagan Nation. I want to acknowledge that some of you might be joining us today from many places, both near and far, and I would like to acknowledge the traditional landowners and caretakers of those lands as well. So just a couple of housekeeping things before we begin. You may see a closed captioning box on your screen, and just to let you know, you can move that to your preferred place by clicking and dragging it, or you can turn it off using the live transcript button on the menu bar. We invite you to type in questions and comments at any time during the presentation in the chat box. And at the end of the presentation, we'll have a chance to read them out to our speaker and have a discussion and invite comments on the topic today. So the webinar today is brought to you by the Institute for Healthy Living and Chronic Disease Prevention here at UBC Okanagan in Kelowna. I'm delighted to have my colleague, Dr. Brian Dalton, today. He's an assistant professor in the School of Health and Exercise Science in the Faculty of Health and Social Development here at UBC Okanagan. And he's going to share some of his research about finding balance. And delighted to have you here, Brian. Welcome, and I'll turn it over to you.
Okay, thank you for the introduction, Joan. Yeah, as Joan said, I'm a faculty here at the School of Health and Exercise Sciences, and today I'll tell you a bit about my research. I'll also talk a bit about maybe ways we can prevent falls as well, and do a brief introduction of what happens with older adult aging. But before I get started, I'd like to acknowledge as well that I'm presenting from the traditional ancestral unceded territory of the Syilx Okanagan Nation as well, and I'm very grateful and that I can be able to play and work in these lands. Okay, so to get started, a brief overview of what I do in terms of research is I'm a basic neuromuscular physiologist or a basic physiologist, and my goal is to find the basic mechanisms of how we control human movement as it relates to postural control. But I do have an interest in how these basic mechanisms affect human function. And some of the things that I am interested in are how small intrinsic muscles within our feet actually help control balance, as well as how our limbs, our upper limbs of our arms and legs, are coordinated to control balance. And I also use various models of research as well, which include hypoxia or a low oxygen environment, sleep deprivation, physical activity, fatigue, and of course, I'm very interested in adult aging. I won't speak about all of these streams of research today, but I will hit on some of those aspects as they relate to adult aging. Why am I interested in studying balance in aging? Well, the fastest growing age group within Canada or within the world is those that are greater than 65 years of age. And this group is increasing year by year, not only in the actual numbers, but also the proportions. And as we can see on the graph here on the right of my slide, by the year 2031, older adults will make up greater than 20% of our population. And then also I'm interested in falls and older adults because public healthcare spending per person per age group is 4 times larger in the older adult categories than the younger adults and middle age groups. Also, well, what we see here in these stats and figures is that for the first time in history, older adults make up the same percentage of our population as those who are 14 years and younger. And it seems that this is driven by our provinces on the 2 coastlines. So BC and then our Atlantic provinces. And the reason I bring that up is I'm originally from Newfoundland. So I have some pictures here on the bottom of my hometown. And then I have a couple of pictures here from British Columbia as well. And it's quite interesting that these provinces are the aging provinces, or the ones that are older than the others. So what causes aging? How can we slow it down? Well, if we just take a step back and look at what causes us to get older is, well, maybe it's our number of birthdays we have. And as we have a birthday, we keep getting older. So maybe we just prevent having birthdays. But chronological aging is not biological aging. It's not a linear process. So I want to talk about a few definitions related to aging before I jump right in. So chronological aging, meaning the years since birth. Biological age is determined by our biological profile or our genetics. And then we have our functional age, which is determined by how well we perform at certain tasks, how long we can stay independent to perform activities of daily living. And I have pictures here on these slides of older adults who are at different stages of the spectrum, or different ends of the spectrum. We have older adults on the left who need an assistive device in order to be mobile, where we have other older adults here who are competing in world masters events. So where I come into play as a researcher is I want to crack the code, so to speak. I want to figure out what are the origins, what are the deficits within balance control at the physiology level as well as the functional level. And are there ways in which we can improve that? Here we have a schematic of the various systems within the human body. And as we get older, we see that there are decreases in function of all these various systems. And you could be thinking to yourself, well, Brian, there's a lot of bad news here. There's a lot of decreases going on in these systems. Well, if we look, there is an increase in some things. There's an increase in fat mass, there's an increase in blood pressure, there's an increase in disease. And I know this is somewhat negative, but I'll talk a bit about the positives as I go along in this presentation as well. So one main observation with adult aging is that there's this decrease in muscle mass known as sarcopenia. And added to this definition is a decrease in strength and power. So there's also decreases in function, which are associated with these biological aging processes. And it's been stated that there may be no single feature of age-related decline more striking than the age decline in lean body mass. And that's important because we need muscles to do everything in in our lives. We need our muscles to be able to speak, to be able to move, to be able to perform all our activities of daily living. But it's not just the muscles that are involved in movement. And this is where I come into play in my research. Yes, we need our muscles, and we need our muscles to be strong and to perform tasks. But we also need the brain and our nervous system to talk to these muscles to allow us to perform those movements. And the main feature of our neuromuscular system, our nervous system, along with our muscle system, is what is called the motor unit. And this motor unit is simply our nerves that are housed within our spinal cord that innervate our muscle fibers within our skeletal muscles that allow us to move. And everything we do, all our movements have to go through this motor unit. So it's the gatekeeper, so to speak, or the final common pathway of activity and our ability to do tasks. With adult aging, there are also some general observations. We have a decrease, or we have an increase in fatigue. We also have a loss of muscle mass. We have muscle weakness, decrease in cognitive function, and we start to get slower. But we also have this loss of balance that's been documented widely for many years. And what also I have here, in terms of the observations, I have two world-class athletes on my slide. And at the time the pictures were taken, both were world champions. But we have a noticeable difference in the amount of muscle mass they have. Even though the older adult is a world-class athlete, they were not as fast as the younger adults. But from my perspective, then what's happening to their balance control? And the reason why I'm interested in balance is that falls are the leading cause of injuries in older adults. And approximately 30% of older adults have at least one fall per year, and that's an unexplained fall. And these falls, all falls, cause about 85% of seniors' injury-related hospitalizations, which can lead to greater than $2 billion in related healthcare costs. And all of these are Canadian numbers. Unfortunately, because there are so many things that may cause falls, little is known about the basic mechanisms. There's not a lot of people like me out there focusing entirely on the basic mechanisms to understand how we can treat balance control and falls. Another reason why I'm interested in balance, it is also personal. So growing up in a small town in Newfoundland, we have very close-knit families as well. And I grew up living with my grandmother, and I observed her health deteriorate over the years, and watching her lose balance control and stumbling at times. And now as I'm older, I'm observing the same thing in my mother as well. She's starting to lose her balance control. So I have a genuine interest in this area. And as I was describing, balance is a complex system which integrates a lot of information from our sensory systems as well as within our brain. It's a complex process, but because we often don't think about it, it often goes unnoticed. until something goes wrong, like a fall. And I found this quote quite interesting. It takes a child 1 year to acquire independent movement, and then 10 years or more to acquire independent mobility or become good at mobility and performing tasks. But all this can be lost within a day in older adults or within an instant, especially when it comes to falls. So I'm quite interested in that. Here I have an example or a schematic of how our postural or balance system works, and what happens is that we receive information from various sensory organs like our muscles, as well as proprioceptors, which are sensors within our skin, within our muscles, within our joints that tell us where our bodies are in space. We also use our vision, and we also use information from our vestibular system. And then what happens is our brain takes this information, it organizes it, processes it, and then it sends signals to our muscles to provide the appropriate responses. And by doing that, it allows us to perform just normal standing balance tasks, or it allows us to perform any other tasks like this person here, this individual here performing a yoga poses. So the key here is that balance is involved in all activities of daily living. We need balance control in order to function. And my primary interest, as I said earlier, is the vestibular system. And you may be asking, Brian, what is the vestibular system? So the vestibular system is located within our inner ears, and the vestibular system are 3D accelerometers that their sole purpose is to tell our brains where our head is moving in space. So these 3D accelerometers, they sense angular rotation, so our head moving circular rotations, as well as linear accelerations and a sense of gravity. So these senses then allow us to know where our head is in space, and the primary goal of that is to ensure that our muscles provide contractions to keep our body upright so our heads don't fall on the ground. And a great example of how sensitive our vestibular system is the cat's vestibular system is quite sensitive. And they have what is called the righting reflex. So you've heard that cats always fall on their feet or land on their feet. If we turn a cat upside down and we drop them, their vestibular system will sense gravity as well as those linear accelerations, and the muscles will right the body, twist the body so that it can land on its feet. Another great example of how sensitive the vestibular system is in birds as well, or owls. And if you watch a video of an owl or even a chicken or a rooster, you see when you move their body, or when a person moves their body, their head is stabilized in space. So they have very sensitive vestibular organs. But we also have very good vestibular organs as humans. And these vestibular organs are important for allowing us to know where our head is in space so that we can keep it upright, as well as stabilizing the eyes and stabilizing our head on our neck. as well as balance and posture control. And that's what I'll talk about in the next several slides, is how the vestibular system is important for balance control. How we investigate the vestibular system in the lab is through a technique called electrical vestibular stimulation. And electrical vestibular stimulation essentially is we place two electrodes behind the ears on top of the mastoid processes, which are on top of the inner ears. And we send these small currents across the head. And I have an example here on the slide. I have a lightning bolt. And what happens is this current activates our vestibular nerves. And by doing that, we can probe how well the brain and the nervous system, or brain and spinal cord, react to when the vestibular system is perturbed or activated. And we can evaluate how well the balance system can do in response to these vestibular stimulations. And then we can evaluate that over age groups, between age groups from young and older adults, or we can evaluate it at a clinical level as well. We can compare some movement disorders to healthy controls and various contexts as well. But what we're interested here, when we evaluate the vestibular system or we activate it with electrical stimulation, we can get a reflex within our muscles. And this reflex can tell us several things. It can tell us how sensitive the vestibular system is to an input. It can tell us how well the vestibular system is functioning. It can also tell us how well we can balance as well, or how well the balance system is working to keep ourselves upright. What's neat about this vestibular stimulation is that when we activate it, it's only going to activate the muscles that are involved in keeping our body upright. So for example, I'm standing here now in front of you. If I were to activate my vestibular system, it's going to activate my calf muscles that are contracting my feet and ankles to keep myself upright. Also, we can see that the vestibular system is quite sensitive in that it activates at a single cell level as well. So what this figure is showing is that the vestibular system modulates single cells, in that it modulates motor units and a group of muscle fibers, so it can evaluate function and single cell or basic mechanisms. And that's another interest of mine. I can go down and actually record basic mechanisms related to this system. But what I'll talk about today is more related to function. Okay, so I'm going back to my overview. The first aspect is what I want to talk about is the role of intrinsic foot muscles. And the intrinsic foot muscles are these muscles located within our feet. And more specifically, the muscles that we're interested in are the muscles that can move your big toe. They're called the abductor hallucis. And you can try that as you're watching me now. If you can try to wiggle your big toe, that would be the intrinsic muscles. And what is observed previously is that these muscles within the feet are important for balance control, in that as we change the postural task demands, so if I go from standing on 2 feet to standing on a single foot, the activity of those muscles increases to try to keep you stable and prevent you from falling over. So these muscles actually are modulated with the difficulty in the postural task. And how we record these is we can stick very fine wires within the muscles to record the activity. Because these muscles are so small, we need to actually go under the skin to record their activity. And we do that with indwelling electrodes, and we have an example of that here. You may be able to see the wires, or if not, they're just that small. Okay, so this work coming out of my lab has been led by some very bright students and trainees. Jonathan Wallace and Megan Trotman led this work, and they looked at how the vestibular system activates the intrinsic foot muscles. And what they found, I won't go into too much detail about the figures, but what they found was that, yes, there is a connection between the vestibular system and the intrinsic foot muscles, such that the intrinsic foot muscles are involved in actively controlling balance. And the foot muscles want to control or keep you upright. So what's interesting as well about these foot muscles is that when we're navigating through our environment, they're one of the first things that comes in contact with our environment. So the feet are a source of sensory information, but also these muscles have a source of sensory information. So every time we stretch those muscles, they have sensory feedback going back to our central nervous system. So they not only activate to keep ourselves upright, but they also sense our world to allow us to have more reflexes to keep ourselves balancing. And what Jonathan and Megan found was that the vestibular system has control over these muscles so that they can actually keep ourselves upright. And when we become less stable, so if I move my feet closer together or stand on one foot, for example, then these muscles will increase their sensitivity or turn up the volume on our other sensory information or signals coming from our brain, so that these muscles can activate more to keep the body upright and balanced. So these foot muscles are important for helping with balance control at the whole body, and it helps increase our stability. What others have found with these muscle groups is that the size of the muscle within the intrinsic foot muscles are also related to how much we sway or how much we move while we're standing. And what's thought is the more we move while we're standing, the less stable we are or the less balance control we have. So what some of the trainees in my lab have done is that they investigated, well, we know that the size of the muscle is important for balance control, or at least related to how much we sway. Well, is the function of those muscles relevant to postural control? So how much strength we can produce with those muscles, or how well we can activate those muscles. And what this group of students found was that with this muscle group, it was difficult in some people to actually contract the intrinsic foot muscle. And you may have found that now as I'm talking and you're trying to wiggle your toe. Some of you might not be able to move your big toe, or maybe you can. If you can, you have very good function with your toes. But what this group found was there's a wide range of people or abilities to contract those muscles. And other thing is they found that they looked at involuntary strength as well, not just the person's ability to produce muscle force or muscle power. They also looked at electrically evoking muscle contraction in those muscles. So they took a pair of electrodes and they electrically activated the muscle of the foot. And there's an example of this on the slide. The red and black lines show how much force is produced when we involuntarily activate these muscles. And what we see, what we can do with this is that we can look at how fast the muscle can contract. So we can look at if speeds are being reduced. And it seems that these speeds are related to how well we perform balance. So we need some quickness in our muscles in order to keep our bodies upright. And what they found in these studies is that there was a moderate to strong relationship with postural balance control. And again, I'll repeat myself, it's likely a key role for intrinsic foot muscles in controlling balance. And the fast speeds, as well as the strength, may help us in balance control. So we may need to maintain that strength as well as maintain that speed within these muscles to keep our balance upright or maintain our balance throughout the lifespan. Now I'm going to take another approach and talk a bit about adult aging. And I talked a bit about how we also have changes within our sensory system as well. So the organs within our vestibular system, they're reduced, as well as our ability to perceive head motion is reduced in older age. And it seems that unexplained falls and imbalance is linked to a vestibular impairment. So what we did in our lab was we went in and we tested a bunch of younger adults as well as older adults. So those over 65, I think for this study, we tested those into their 70s. And what we found was that the older adults had a larger reflex, so a larger reflex than younger adults. And throughout this talk, I've been saying that older adults have all these decreases, right? But for the vestibular responses or balance responses, older adults seem to respond to a larger extent than younger adults. So we want to know why that is. Well, one way we can do that, or another way we can test the vestibular system, is to provide rotations or mechanical rotations. And what we did in this experiment was we had participants sit in a chair like I have here on the slide, and we rotated the subjects or participants around an axis in this chair slowly. And we asked the participants, could they perceive the spinning of the chair? So very slow spins, and we asked them, could they perceive the rotations? We also did another context or another experiment where we did this virtually as well. So we stimulated the vestibular nerves with electrical vestibular stimulation and had them perceive that they were rotating around as well. And what we saw was that at certain frequencies, older adults were better at perceiving the vestibular rotations than the younger adults. So here on these figures, lower values equal better performance. So the older adults were better at perceiving at certain frequencies, especially at a 1 hertz frequency. And what that means is that older adults, larger postural reflexes than younger adults. And it seems that the older adults have this compensation within their brain for the age-related reduction that we so decreases, turns up its amplification or turns up its volume speaker to say, hey, I can't hear you. So it can't hear the sensory feedback. So it turns up that volume knob so that we can have a response to all these decreases that are happening. So the brain tries to compensate as we age to maintain balance control. And it seems that it tries to maintain a frequency that is important for tasks of daily living, in that the frequencies that are important for us performing tasks of daily living, like standing at the sink washing dishes, or us moving around, walking from one end of the room to the other, the frequencies that are important for those tasks are the ones that the brain is amplifying in the vestibular system to maintain balance. All right, so also we have some other trainees that led more work on this vestibular system. And what they found was, again, that instead of just older males, this time they looked at older females. And we do know that there is limited data on older females and females in general. So we do need more work out there looking at physiological function as well as balance control in females in general. And what this group found was that, yes, same thing as in males, there is a larger reflex or a larger balance response in older females than younger females. But the interesting fact here is that what this group found was that they saw that older females that are weaker or less powerful had larger responses. So again, not only does the brain compensate and try to compensate for reductions in sensory as well as other neural decreases, it also tries to compensate for decreases in muscle power. So it tries to compensate for decreases in our muscles' ability to produce force as well as power to keep ourselves upright. So it sends greater signals to our muscles to ensure that we stay upright. And that's what I just said here. So as a take home, older adults have larger balance responses as well. This relationship is, there's a relationship between our vestibular system and our muscle power, meaning that weaker or less powerful individuals have a larger response. And this is the same whether you're an older adult or whether you're a younger adult. If you're weaker, you have a larger response. Okay, so as we're coming close to the end here, I want to talk a bit about fatigue as well. And this work was led by Jonathan again. And what previous studies before him saw was that with fatigability of muscle power, that's related to muscle function, or at least function during tasks of daily living, such as balance, as well as the ability to walk fast. And what this trainee did was that he looked at muscle power over multiple contractions. So he fatigued the lower leg, and he saw that with multiple contractions, the older adults were more fatigable than the younger adults, but specifically not just in strength or power, they were more fatigable when they tried to move faster. So their ability to move fast, or the rate at which the muscles can contract, were impaired more over a short period of time in the older adults than the young. So what we want to do now is, this work will be led by Lisa Ha in my lab, is that how does fatigue and those rates of activation, how does that affect balance control? Because we think that the rate of activation or ability to move quickly is what hinders our balance performance, at least at the muscle level. So we want to look at now what happens if we fatigue the muscle, and if older adults are more fatigable, then what's going to happen is that we're going to start losing more muscle power, and our ability to actually perform balance tasks and perform activities of daily living may be reduced even more. So bringing it together then is that with adult aging and function, we have these decreases, but we also have some ability to try to compensate for those decreases. And with these decreases, like slow contractile speed, reduced strength, reduced power, we do have a loss of function and independence. But at the same time, our brain tries to adapt to these reductions and increases the output in order for us to try to stand. But if we increase it too much, and we do have these reductions in power at the muscle level, this may actually lead to increases in falls as well, because we may be pushing ourselves too far or outside our limits of stability, and we may fall over because we're reacting to postural perturbations too much. And one of the reasons I'm interested in this as well is that with age, we start losing strength or power, and we all work on these functional thresholds. So you need a specific amount of strength or power to perform tasks of daily living. And we need to try to stay above that functional threshold. So if we have fatigue, or let's say you're moving about all day, then that fatigue may bring you closer to a threshold, which may lead to a fall or a balance impairment. So we need to try to stay above that functional threshold. So the takeaways from this talk today is that sarcopenia is a critical aspect of aging, right? We have reductions in muscle mass, but it's also accompanied by reductions within the nervous system, and our brain tries to compensate for that. But as well, balance is important, and it can be activated by or aided by muscles within our feet. So we can focus on muscles within our feet to help control balance control. As well, older adults have a larger vestibular response or balance response than younger adults. And this is a way for the brain to try to compensate for decreases within our muscles as well as our sensory systems. And balance is negatively correlated to power. So meaning that we likely need to focus on activities that maintain our muscle power and strength as we age. So we want to try to do activities to maintain our power. We also want to try to focus on endurance activities so we can maintain our muscular endurance so we're not fatiguing too much. And we want to try to focus on maybe the muscles within our intrinsic feet as well, or intrinsic feet muscles that could help aid in us being aware of how we're balancing. So that's where I'm going to end today, but I'll leave you with this quote from Cicero, meaning that we have to try to resist old age and fight against it as we would fight against disease. So we need to adopt the regimen of health and practice moderate exercise so that we can maintain a healthy lifestyle and maintain activities of daily living as well as function. So to end, I just want to thank my collaborators as well as my funding. And I couldn't do any of this work without great trainees. And I've been very privileged to work with very good trainees. So here, some of them are here on my slide, and I'm happy to answer any questions that you have.
That was fabulous. Thank you so much, Brian. And I forgot to mention at the beginning, but October 1st was International Day of the Older Person, and in part why we invited Brian to give this talk in early October, in part to celebrate older adults. And we do have questions and comments already in the chat. So the first is, and I know you haven't talked about this, but I wonder if you have any thoughts or know anything about how deafness might affect our blindness, our balance, sorry.
Yeah, there is work out there on how limited hearing affects balance control. And so what's interesting is the auditory system and the vestibular system share the same nerve branch going to the brain, and they do work together. So decreases in the auditory system in hearing does affect balance control. So yes, when you lose your hearing, it will affect balance control, because that's one of the senses we also use to navigate our world.
Great. We've got a question from Catherine as well. Generally speaking, do supinators have more of a problem with foot stability, and I'm assuming then balance, than pronators? What do you think?
I'm going to say she may know more than me. But so what we're focused on is how these groups activate, mainly is how we can spread our toes. So that's the function of the two muscles that we're quite interested in, is the abductors, which pull the toes apart and give you a greater base of support. So by doing that, it provides a greater base of support and may increase stability. But I'm not familiar on the rehab side of things that talk about supinators versus pronators.
And what about foot size? You know, small feet, I'm assuming, have smaller muscles than larger feet. So I'm a person with a very small foot. So now I'm worried about my balance. I don't know how many muscles I've got there.
So it's both, right? So what happens is, if you do have large muscles and large feet, you will have an increased base of support, but your brain needs to be able to activate that muscle. So for example, one of the strongest participants that I showed you in the intrinsic foot muscle strength was actually our smallest individual, or the person with the smallest foot, because they knew how to activate their muscle quite well. So if you know how to activate those muscles, you're good.
Okay, that's great. All right, we have a comment from Nova about a prescription for systematic antifungal prescription, which she took, and it played havoc with balance. 3 falls during that time. It felt like the medication stressed the body generally and maybe impacted the speed of the brain's interpretation of visual signals being received. Any comments to that?
Yeah, I guess I'm not familiar with the antifungal cream or medication, but there could be. Well, let's take a step back and look at if there's some anesthetic creams out there. They could decrease some skin receptors on your feet, which if that's an issue, then if you don't have skin information on the feet, which is another important sense for balance control, that could alter how you're balancing.
Yeah. Yes, and she went on to comment, it was like I couldn't get my body to autocorrect the way it normally would. And
Yeah,
so that in some ways would make sense.
Yeah, if it has some anesthetic properties in it, then you won't have those quicker reflexes because you're not sensing the world under your feet.
Yeah. Comment from Judy. Thank you. This is very interesting. So that's great. Thanks, Judy. And then Barbara asks, when you say move your big toe, do you mean just your big toe and not the other toes at the same time? Like, what do you mean by that?
Yeah, so in the experiment that we did, we just had the person move their big toe, which is quite difficult for a lot of people because we don't do that type of task. But most people might be able to spread all their toes at the same time, which is a little easier. But so yeah, that's exactly what we mean, is just moving your toe at once. But for balance control, how we tested, that was the strength test, was just move that one. But for balance control, it would be you need to move all your toes together in order to maintain proper balance.
Right. And so should you be doing some exercises with your toes to like keep up that muscle strength and endurance?
Yeah, there's some work out there, some strength interventions out there looking at how strengthening the foot muscles improves balance control, as well as that's theory behind some of those trail running shoes that you see with just the single toes out there, so that you are knowing how to move those digits.
Ah, interesting. I might have to try those. Jane, I'm not yet 70, but already have balance problems when standing and walking, even on smooth surfaces. For example, walking even 2 blocks is more than enough. What's the best way to get balance back without making things worse? Actually, that's a pretty good question.
Yeah, no, that's good. So one thing is, you don't want to stress the situation, right? So if something is giving you complications, then you don't want to keep stressing it. My suggestion would be to find a vestibular practitioner. They would give you some very good advice on vestibular types of activities to do. Whether it's moving your head back and forth while focusing on a area on the wall while walking, so that you can start learning again how to integrate your sensory signals with the movements. That seems very important. So being able to use your sensory systems while doing other tasks, because what happens as we age is we start becoming more voluntarily driven, I'll say, in that we need to voluntarily activate our balance system, as opposed to in younger adults, we don't need to think about it. You see younger adults, they walk and they carry on multiple conversations and they talk on the phone and text at the same time. But if I'm walking and I need to check my phone, I need to stop and be able to text someone. And then as we get even older, then we need to start thinking about producing those contractions with our muscles. So it's trying to maintain our abilities to almost multitask per se. But yeah, I would, there are a lot of good PTs out there that perform some of these prescriptions and interventions of vestibular rehab that would be very helpful.
Great, great. Well, Jade and Patricia and I have the same questions about exercises targeting the feet to increase balance. And are there any interventions? Like, is there more than just, if we don't want to buy one of those trail running shoes, is there something else we could be doing?
Yeah, it's because those muscles are somewhat smaller. I couldn't activate those muscles, I would say a few years ago. But it's simply just sitting at your desk and trying to move your toes, thinking about it while you're there. And chances are you'll probably start being able to move your toes. I'm doing it now as I'm talking. But yeah, that's what I did. When I'd be sitting at my desk working, I would be trying to wiggle my toes independently so that I would have some function, and it seems to help. I haven't done an intervention study, I'll preface that, but I definitely have better control of my toes now.
Yeah. Another comment that this has been very interesting, and a comment, I was told to wear my Birkenstocks to keep my foot muscles working better. So any thoughts about the type of shoe that you wear?
Yeah, so like the trail running shoes, it seems that when you're confined to shoes that are at least immobilizing your foot, those groups of people have more difficult times activating their toes. So for example, hockey players, anecdotally, when we test hockey players in the labs, they have very poor control of their feet because they're confined to a skate all the time. But those who do yoga, for example, or dancing, they have very good control of their toes. So activities that allow the foot to be free from confinement will definitely help.
Great. And another comment about being a hiker since my 20s, now I'm early 60s. Just between the ages of 60 and 61, I had 3 falls hiking, just walking in the woods and then flat down. No stumble, nothing, and was up then down. My husband said I tripped on branches each time, but I didn't stumble. I just went right down. And this has never happened before. The last fall, I broke my arm. It's been a year since that. We don't realize why we don't realize what I'm falling while it's happening. I have no memory of what was happening from going up to down. So it just, all of a sudden, you're down on the ground.
Yeah, unfortunately, a lot of people describe that. So earlier when I was talking about my mother, that's exactly what she experienced as well. And yeah, it's difficult to pinpoint because there are so many systems within our balance system, including the vestibular system. Any one of those could be going wrong and we don't notice it until it happens, unfortunately. So it's going through and trying to pinpoint what system is actually being affected. If it's a vertigo type issue, it's usually linked to a vestibular issue, but then it's tough to find the issue when it's something that you can't quite pinpoint.
Great, thank you. Carly, just complimenting the presentation, insights, and definitely sharing with my clients and using this in clinical practice as a physio. So thanks again. And then a question from Jaquetta. Do yoga balance poses help develop foot muscles? I struggle with 1 foot poses. I think I would too.
Yeah, I think it does, Jaquetta, especially to create that base of support when you're standing on one foot. If you have an ability to spread your toes out to increase that base of support, it should be able, because they talk about grounding in yoga. So
Mhm.
if you can ground that foot with by spreading your toes, then that would help.
Yeah, great. Norma asks, can you address the impact of bunions and muscular impact as part of aging and impact on balance?
Yeah, so I would think bunions may alter how your cutaneous receptors or the skin receptors within your feet may be activated. So as a young people, then your skin is very, I'll call it springy, and it can be used to activate sensors. So the receptors within your skin will deform to anything. But if you have, let's say, calluses or bunions, for example, on your feet, then your skin is not going to deform as much when you're walking or balancing, for example. Then you're not getting the same amount of information as you would without those types of callous skin or hardening of the skin.
Mhm. Well, there are a few more questions, Brian. This has been a great talk today and obviously generated huge discussion and questions, but we've run out of time. So I encourage people who we didn't get to your comments or questions to contact Brian Dalton at UBC. I know he'd be delighted to hear from you. And I do want to thank you once again for joining us and sharing this research and getting us all thinking about how we can preserve our balance by doing things with our feet. It's something I hadn't thought about before. So you've given us lots to think about. So thank you once again. Thank you to everyone who joined us today. Really appreciate your support and interest in aging and health. And we look forward to seeing you at one of our next webinars. So thanks again, everybody. Thanks, Brian. Have a good afternoon.
Thank you.
Bye-bye.